Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 8, Lesson 3, Finding a Percent Using a Product. And let me be very specific about what we're going to be achieving today. We're going to be working just the types of problems where I give you some kind of total. Let's say there's 50 people on a bus. And I say, let's say 12% of them brought their lunches with them. What number of kids brought their lunches? So I want to find a percent, given that I know the percent itself, 32%, 12%, 18%, and I know the total. All right, that's what we're getting at today. And we're going to see how finding a percent of a total really just boils down to finding a product that, sorry, but unfortunately involves a fraction. Anyway, let's get into it right now. Here we go. Finding a particular percent of a whole quantity can be done using a percent ratio, and that's what we've been doing for the last few lessons. But it can also be done using a product, and that's what we want to understand in today's lesson. So let's take a look at exercise 1. There are 400 total students in a high school. A double number line below shows how this corresponds to percent. Answer the following questions. All right. So by the way, let's just take a look at this double number line. Let me kind of move it up to the top of the screen so we've got the whole problem there, right? I mean, it should be easy, right? You know, you got the 0 to 400 in terms of the students and 0 to 100 in terms of percent. And obviously the 400 students corresponds to the 100%, right? Likewise, right, 200 students would then correspond to half of that, or 50%, all right? So it kind of all makes sense. But let's take a look at something a little bit more challenging. Let's take a look at letter A. If 5% of the students transferred into the school, how many students transferred in? Show or explain how you found this. All right, now this is a little bit trickier because of the way the number lines are scaled, but I want you to see if you can use this double number line to help you figure out what 5% of 400 is. Pause the video now. All right, well, you know, we can easily see that 5% lies right here on the number line. The question is, what would lie up here on the student part of the number line? So the 5 on the percent part of the number line is pretty easy, but then up here, right, there is no number here. But we can see that it's 0, something, 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 100, right? So we can see that this 0 to 100 is divided up into 5 equal parts. That's irrelevant compared to that 5. Doesn't have anything to do with it, right? 5 equal parts. So if I want to know what sits there, all I have to do is take that 100, divide by 5, and I get 20. And again, that makes sense, right? I'd have 20, 40, 60, 80, 100, 120, 140, etc., right? So it's going to be, well, I already have that down. It's going to be 20 students transferred into the school. Now, letter B, this is probably the most important one of the day. Take a look. How many students does 1% of the total number represent? How can you find this easily based on the total itself? Right, so I just want to know what 1% of the 400 is. So here I'm at 5%, and that corresponds to 20 students. What would I have if I was down here at 1%? How many students would be sitting right here? I'd like you to pause the video and think about this right now. All right, well, it's pretty simple, right? If 100% equals 400 students, right, then 1% equals 4 students, right? And how can you find this based easily on the total? Well, divide by 100, right? Divide by 100. That's it, right? If 100% corresponds to all 400 students, then 1% of that would just correspond to 4 students. And by the way, take a look at that. Back here, right, 5% corresponded to 20 students. Well, 5 times 4, right? If 1% is 4 students, then 5% would be 20 students. So that kind of checks. All right, let's take a look at letter B. or C, I guess, based on letter B, if 27% of the students are ninth graders, how many ninth graders are there? All right, well again, now we're going to scale up, right? 1% was equal to 4 students. Remember, this is all really kind of ratio work. Hi, Red S. 4 students. Then 27%, right? To go from here to here, you'd have to multiply by 27. So I'm going to multiply by 27 as well here. So I've got, 27 times 4, 8, 2, 8, 108, 108 students. Now, very important, letter D. What single number could we multiply the 400 student total by in order to find the answer in C? All right, so in other words, I want to get this 108 by multiplying 400 by a single number. Spoiler alert, it's a fraction, all right? So we're going to have to multiply 400 by some fraction to get 108. And the key is what we did in both letter B and in letter C. So in letter B, we took the 400 and we divided by 100. And then in letter C, we took that result and we multiplied by 27. So what number can you multiply by that will both divide by 100 and multiply by 27 all in the same calculation? Think about that for a second. Well, we would simply multiply by 27 100ths, right? Multiplying by 27 100ths, literally multiplying by the percent ratio, will divide the total up into 100 parts and then find the value of 27 of them. And that's what really it means to find a fraction of a total in the first place. Again, let me say that one more time. If I had some total and I said, hey, find 2/3 of it, you would multiply by 2/3, which would mean dividing the total by 3 and then multiplying what you got by 2. All a percent is a fraction out of 100. So if I'm finding 27% of a total, I'm really finding 27 100ths of it, meaning that I'm going to divide by 100, get a result, and then multiply by 27 to find out how many 27 100ths is. And that's all finding a percent of a total is. It's really just about multiplying by that percent ratio or that percent fraction. So let's get some more work on that in the coming problems. All right, finding the percent using a product. Finding p% of a quantity means dividing the total into 100 parts and then taking p number of those parts. We do this by multiplying by p over 100, or p hundredths, or p out of 100. That starts to sound a little weird. All right, let's take a look at exercise 2. Let me get that up to the top. All right, exercise 2. Fill in the missing blanks for each statement. Finding 40% of a total can be done by multiplying the total by, again, it's easy as this, by multiplying by 40 100ths. That's it. I can find 40% of any total by breaking it into 100 parts and then finding 40 of them. And that's equivalent to multiplying by 40 100ths. This is pretty easy. How about letter B? Finding 85% of a total can be done by multiplying the total by, well, again, no need to pause the video. All we need to do is multiply the total by 85 100ths. Now, I know multiplying by fractions is not your favorite thing, okay? But keep in mind that when you multiply a number by a fraction, you're multiplying by the numerator and you're dividing by the denominator in either order. And division by 100 isn't the worst thing on earth, right? Because then we just have to move the decimal place 2 units to the left. Let's get some practice on this and some applied problems. Here we go, exercise number 3. Find the answers to each of the following percent problems by using a product. Show your work. These will generally work out nicely. Letter A. 32% of 500 people who attended an outdoor concert brought lawn chairs. How many people brought lawn chairs? All right, so we could totally solve this problem, and I don't want to discourage you from doing this. We could definitely solve this problem by setting up equivalent ratios, thinking about how to scale the ratios and all of that. But at the end of the day, Knowing that 32% of people brought lawn chairs means that 32 100ths brought lawn chairs. So we want to really find 32 100ths of 500 people. Now, if it makes you feel better because when you multiply a fraction by a whole number, you like to see a denominator on the whole number, feel free to put the 500 over 1. If you feel that need, that's okay, right? The great thing is that 100 then will cross cancel with 500 to leave me with just 5. And now I'm just looking at 32 times 5, which maybe I need to, come down on the bottom of my paper, and do this. But I get 160. 160 people must have brought their lawn chairs. And that's exactly what we would get if we had done something like this instead. If we had kind of set up these equivalent ratios and we thought about, I have to multiply by 5 here, I multiply by 5 here, that would then get us that 160 in the numerator, all right? But we want you to understand that really finding the percent of a total means dividing it into 100 parts and taking that many parts. And that's what I did, right? I took the 500, I divided it into 100 parts. There were 5, people in each part. Then times 32 gave me 160. Let's do another nice one. Letter B. On 13% of 1,000 participants in an online quiz passed. On 13% of 1,000 participants in an online quiz passed. How many people passed? That's not quite right. It should just say 13% of 1,000 participants in an online quiz passed. How many people passed? All right, so try to set this one up as well with a product and figure out how many people passed this online quiz. All right, let's do it. So again, 13% tells us the fraction was 13 100ths. All right, we want to multiply that by the 1,000 people who took the quiz. Again, if you like the 1,000 over 1, do so. 100 divides into 1,000 10 times. 13 times 10 is 130. All right, so 130 people passed. Very, very easy. Finding the percent of a total means multiplying by that percent ratio or that percent fraction. Now, these were all pretty easy because I made the totals to be nicely divisible by 100. But of course, in most situations, the total isn't nicely divisible by 100. It isn't 200, 300, 1,000, or what have you. It can be messier. So let's start taking a look at those situations. Exercise number 4. Find the answers to each of the following percent problems by using a product. Show your work. These will be more challenging. Letter A. Of 75 eggs inspected at the store, 8% of them had cracks. How many eggs had cracks? All right, so again, we could do our business that we did in the last 2 lessons. 8 over 100 equals what over 75, etc., etc. Nothing wrong with that. But the point of the lesson today is to say, well, all right, 8% means 8 out of 100. All right, and what we want to do is multiply that by 75. Again, if you want to do that, great. All right, these are more challenging because obviously 100 doesn't divide into 75 nicely. But you can definitely multiply fractions the way you always have. In other words, I could divide this by 25 and get 3, divide this by 25 and get 4. I now could do 8 times 3 and get 24. I could do 4 times 1 and get 4. And then I could say 24 divided by 4 is equal to 6. So 6 of the eggs had cracks. All right, I wouldn't even have to do the cross canceling. If I wanted to, I could just do 8 times 75, get a number, 100 times 1, get a number, and then do the division. But if I can make it easier by doing cross canceling, awesome. Let's take a look at letter B. 55% of 120 people like ketchup on their hamburgers. How many people like ketchup on their hamburgers? All right, why don't you pause the video now and play around with this particular product. All right, well, let's do it. So again, 55% tells me that the fraction of people that will have ketchup on their hamburgers or like ketchup on their hamburgers is 55 out of 100. So I'm going to then multiply that by 120. Okay. Again, it might be easiest if we first do some cross canceling. So both 100 and 120 are divisible by 20. All right, if that's not obvious, you could certainly divide them both by 10. That should be a little bit more obvious. So if I divide them both by 20 though, I'd get 5 in the denominator there and 6 in the denominator there, right? So I now have 55 times 6 divided by 5, all right? So maybe over here I do 55 times 6, and I'll get 30 and then 330, all right? So that's going to be 330 divided by 5, and then maybe over here I do 330. I divide it by 5, I'm going to get 6, 30, 30, 6. I got a lot of 6's in this problem. So I get 66. Now, if you got 66 in a different way, that's great. I mean, if you did 55 times 120, got a rather large number, and then divided that large number by 100 and got 66, that's awesome. Remember, when we multiply a fraction by a whole number, or if you want to think about it as a fraction times a fraction, there's a lot of different ways we can go about doing that. We could do the division first, then the multiplication. We could do some cross-canceling if possible. We could have even, after we did the cross-canceling, we could have then done 55 divided by 5, gotten 11. 11 times 6 would have gotten me 66 as well. Lots of different ways to get to that endpoint. Now, we should look at one final situation, which is when our answers aren't even whole numbers. Maybe our answers are decimals. Let's take a look at that for our last problem. Exercise number 5. Find the answers to each of the following percent problems by using a product. Show your work. These will result in answers that contain decimals. Letter A. Danny must pay 7% tax on a shirt that cost him $34. How much tax must he pay? All right, so a tax is simply an additional amount of money that you pay on a product that you've purchased that goes to the government. It could be the state government, the local government, the federal government, whatever. So in other words, we need to find what 7/100ths of 34 is. So, all right. Now in this case, this is just not going to get very nice. All right, there's no getting around it. When the problems don't reduce nicely and all of that, what I tend to do is do the numerators, multiply them together, and then divide by 100. So let's look at that approach. Over here, I'm going to find what 7 times 34 is. All right, that's 28. 7 times 3 is 21, plus another 2 is 238. So this is going to be 238 divided by 100. Now, one of the nice things about division by 100, as we should already know, is that all we have to do is move that decimal place 2 units to the left, and we get 2.38. And we could have done that in the previous problems as well. We could have just multiplied the two numerators together, gotten a large answer, had it divided by 100, a 100 in the denominator, and then just move that decimal place 2 units to the left, like we did here. All right. There were just easier ways maybe of doing it. Let's take a look at letter B. 52% of a candy bar that weighs 60 grams is sugar. How many grams of sugar are there in the candy bar? Fantastic. Pause the video now and see what you get. And again, it's going to involve a decimal. All right, let's take a look. So in this particular situation, we've got 52 100ths, and we're multiplying it by 60. Again, you can do some cross-canceling here, though. I'm going to take the approach of doing 52 times 60. I'll do that over here on the side of my paper. All right, 0, 0, 0, 12, 31. I'll get 3120. So that means I'm going to have 3,120 divided by 100. And the great thing again is that the division by 100 is so easy. Gives me 31.20. I don't need that last 0, so I think I'm going to leave it off. 31.2 grams of sugar. And that's it. Again, this approach that we did in exercise 5, you could use for every problem. Okay, every problem you could multiply the numerators together and then divide by 100 by just moving the decimal place 2 units to the left. A lot of students like that rather than the cross-canceling and the reducing and things like that, just because it kind of works every time, whether your answer is a decimal or a whole number or anything like that. It just can take a little bit longer, that's all, just because the multiplication here could be a little more challenging. All right, let's wrap this up. Today is a very important lesson because it really gets at this idea of what it means to find a certain percentage of a whole. And what that always means is dividing it up into 100 parts, even if those parts have like ugly amounts in them, decimal amounts, and then multiplying by the percent indicated. So if I'm trying to find 72% of something, I'm going to divide that something up into 100 parts and then multiply by 72 to find out how much is in 72 out of the 100 parts. But that's all really a percent is. A percent simply is a fraction. It just happens to be out of 100. So if we're finding a fraction of anything, we multiply by that fraction. And if that fraction is 72 hundredths or 32 hundredths or 50 hundredths, that's what we multiply by. All right. We'll work with this a little bit more in the next lesson, and then we'll kind of leave percent for the most part behind until Math 7. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.